Okay, so a quick explanation of question number 2. Okay. It asks you from the seismogram on figure 1, and that was the seismogram on the very first page. It's asking you to determine what the difference in arrival times between the first P wave and S wave are. Is it 3 minutes, 7 minutes, and 10 minutes? And it just says to circle your answer. So let's go look at it again. Here's our first P wave arrival. Here's our first S wave arrival. Each line from beginning to end is 1 minute difference. So we start here, that's time 0. This is 1 minute, 2 minutes, 3 minutes. 3 minutes. So you should be circling 3. Okay? All right, last question. And this one's a little bit more complicated, but it says to refer to the travel time graph again. That's the graph here that we looked at in the last video. And it asks you, what is the distance from the epicenter to the station that recorded the earthquake in this figure 1 when we did it? So we're saying, what is the distance to the epicenter at 3 minutes difference between the arrival of the P and S waves? Okay, so let's look at our graph. Now, I know that naturally you're going to try and start by going to the y-axis and going to the 3 and then coming over. That's not how you do this part. What you're looking for is the part where you're trying to find where 3 minutes is between P and S waves. And since they don't just naturally fall on all the lines, you kind of have to use your rules of deduction. We already showed earlier that at 700 miles, it was 2.5 minutes difference. So I know it can't be less than 700 miles because this was already 2.5 minutes, right? So what I need to do is I need to start looking this way, and I know that it's got to be larger miles. So this was 2.5, and I'm going to just step over to the next biggest line because that's really kind of the easiest one to read. And I'm going to go down to that line, and I see that it crosses here and here. So I'm going to go over, and I'm going to extrapolate over, and I'm going to say, hey, it's like kind of 6.8, and this one here is about 3.4. So 6.8 minus 3.4 is 3 minutes. No, 3.4 minutes. 3.4 minutes difference from 6.8. If I subtract 6.8 minus 3.4, I get 3.4 minutes, but I want to find 3 minutes, correct? So I know it has to be less than 1,000 miles, but more than 700. So I'm going to step down 1. This line here is 900 miles. So I'd use my ruler for 900 miles, and I'll draw a line up. Hopefully I can hold the ruler okay. Until it crosses both the P wave and S wave lines. I've got about there and about there. So this is a little bit above 3 and a little bit above 6. So let's say it was 6.1 minus 3.1. That's 3 minutes. So the answer is 900 miles. You have to do this using information given to you in 3 other seismograms. There's a chart to fill in with answers. I'm going to cover them up because I don't want you getting my answers. And what you should note about the chart is it says Los Angeles, then St. Louis, and then Houston, Texas. And if you come over here and look at it again, they're not in the same order. So make sure when you fill in your information on the chart that you do give the correct information. Los Angeles, this one is Houston, Texas, and this one's St. Louis. So double check yourself when you're filling in the chart. If you need any help reading those time distance graphs, rewatch this video. Thanks. I'll see you guys tomorrow. Bye.